Hello, everyone. Chalk Talks are my favorite kind of sessions at reInvent because every session is unique, enabling meaningful discussions and giving everyone in the room the opportunity to learn from each other. Unfortunately, they are not recorded. So I decided to record the intro of my Chalk Talk at reInvent this year and share it with you here on LinkedIn. This Chalk Talk was intended for professionals such as SREs, DevOps, or architects who are looking to boost their web performance to keep their users coming back. My goal of this Chalk Talk was for the audience to get out with some ideas to improve their web delivery and learn about the latest released features of CloudFront. And there was quite a few of them this year. All right, so let's get started with a very common architecture for delivering static frontends, such as single-page applications or statically generated ones. The website artifacts are stored in an S3 bucket and served to users on the main domain using CloudFront, such as www.example.com. CloudFront is the content delivery network of AWS. You all know that. We recommend it on a daily basis to all of our customers as a foundational building block of any well-architected web application on AWS. And this is because it allows you to deliver websites faster, cheaper, more securely, and more reliably. CloudFront is a very mature AWS service that was announced maybe 16 years ago with the vision of making large and globally distributed server capacity available to any developer with simply a credit card. So back to the architecture. Now you want to make the website interactive by hydrating the front end with APIs. For this, you serve an API, let's say on a domain such as api1.example.com, let's say fulfilled with a Lambda function behind API gateway. Note that in API gateway, if you choose the edge optimized endpoint, you will be using a CloudFront distribution that is managed by API gateway behind the scenes. If you are serving your APIs using an application load balancer, the ALB team just provided a simple integration with CloudFront in their console. So that allows you in the UI to quickly spin up a CloudFront distribution with the WAF, Web Application Firewall, to serve your API. Unlike with the edge optimized endpoint of API Gateway, it's not a managed distribution, so you have the full control over it. Let's look at the flow of the request to the web page. First, the user downloads the main page components using the main domain. Then, when the user interacts with the page, the front end makes an API call, for example, to fetch a product information. However, this request will be blocked by the browser. Take a second and think about why that's the case. Well, this is because of the CORS standards. It's a client-side security mechanism, so basically enforced at the browser, to prevent domains for making unauthorized requests to other domains. So for you as a customer, you need to do an additional configuration, for example, on the API gateway, to allow specific domains to be accessed for your APIs. It's not, it's not simple tasks. Sometimes it's complicated things. And I've seen many customers just doing it in a very permissive way. For example, using the wildcard directive, which kind of defeats the original purpose of this standard. So this is called a very simple CORS request, but things can get even more complicated. So let's say you are using instead of a REST API, an API based on GraphQL, right? So the front end in this case sends the query using a post request, and the API query is included in a JSON object in the body, in the request body. Okay, it's a very common scenario, right? GraphQL based APIs are very popular. So what happens in this case? In this case, the browser, according to the CORS standard, has to first send a pre-flight request using the options HTTP verb. So this can happen in different conditions. For example, when another condition is when the front end needs to access to special headers from the response. So this is not without any impact, right? Think about the additional latency that is caused, and think about the additional request cost, request fee that is incurred at CloudFront level. So we actually learned this from IMDb. If you're a cinema fan and let's say you want to get some information about the latest movie you like, if you are in London at the time, you would get, according to them, 80 millisecond hit for every API request, and 200 milliseconds if you were in Mumbai. So IMDb kind of reduced the impact of this by implementing some browser caching for cores on the same, I mean, for the same user, which brought down their, like let's say, transactional request per second from 2,600 to 1,500. And they started to respond to pre-flight requests directly from CloudFront using edge functions. All right, is there a way to solve this problem in a radically different way? Well, yes. We can simply get rid of cores by using the same domain name to deliver the front end and the APIs. And it's quite simple to do it using CloudFront. So using cache behaviors, you can instruct CloudFront how to route requests. For example, the default cache behavior routes requests to Amazon S3, like to the S3 bucket, and more specific cache behaviors such as the /API GraphQL or the other one will route requests to the appropriate API endpoint. This works with endpoints that are hosted on AWS, but also if they are hosted on-prem. And we recently launched the possibility of using endpoints hosted on AWS in a private subnet in your VPC, such as application load balancer, network load balancer, and EC2 instances. So basically, you can keep your load balancer in a completely private subnet, isolated from the internet, and use it as an origin for CloudFront. The feature is called VPC origin in CloudFront. So the way I'd like you to think about CloudFront is using the following mental model. So CloudFront can be used as the entry, like it's the entry door of your application. It's a globally distributed reverse proxy on which you will be enabling, let's say, bells and whistles on your different API or like routes in the application based on your needs. For example, you can enable features related to performance, let's say caching on your static routes or compression for images or for text objects. And you can use edge functions to, let's say, offload some of the logic from your origin to the edge, like IMDb just did to manage pre-flight requests. The other thing very important is to implement security controls at the edge, which is a very important place to do that because it allows you to block threats before they even come to your origin, to your infrastructure, which can be sometimes too late, such as with DDoS attacks, right? So the main service to use here is AWS WAF. That allows you to deal with different threats such as DDoS, bot, automated bot traffic, or dealing with application vulnerabilities and so on. And note that we just recently announced that every request that is blocked by AWS WAF will not be billed with CloudFront. So you'll not get the request fee and the data transfer out with CloudFront, although you will be paying the WAF processed request. In addition, you can implement some kind of middleware. Let's say you have a lot of APIs, microservices, and instead of implementing some shared common logic in every microservice. You can do it at the edge in a single location, right? So you want to do some, I don't know, geo blocking, some HTTP redirection, some authorization, A/B testing, things like that. Then you have all the possibilities for implementing advanced routing, failovers, load balancing, helping you with multi-region deployments, and we will kind of see an example later on that. Finally, if you would like to enrich, let's say, your technology stack with one of the AWS partners, you have usually different ways of doing the integration. You can do the integration directly in your infrastructure, and you can do it at the edge. Maybe you want to benefit from let's say low latency implementation, or you have a legacy application that you cannot change, right? So for example, let's say you want to use a feature flag capability to implement A/B testing, or if you want to use some, let's say, advanced security vendor for API security and so on, you can do it at this level with integration using Lambda at Edge, one of the edge functions available in CloudFront. All right, so what are the benefits basically of using a single domain to deliver your front end and your APIs at the same time? So as you mentioned, we don't need to kind of think about cores anymore. And this, I mean, think about it. It gets even like order of magnitude, I would say, more complex if you are implementing some of the advanced threat mitigations of AWS WAF, typically the ones that requires client-side integrations, SDKs, and so on. It makes it much, much easier. Of course, you don't have the penalty of this additional pre-flight request in terms of cost and latency. And think about your APIs having higher throughput, because they are actually going to happen on already warm TCP or quick connection by the front end. So is there any trade-offs? Yes, always there are trade-offs. I'll give you like a couple of examples. The first one is related to security. So maybe you are only using AWS WAF for your APIs. When you have like separate domains, you can do it in a granular way. Now, once you put everything on the same domain on the CloudFront and you use WAF, WAF will be processing all requests. So you'll be incurring WAF costs for all requests processed by CloudFront. However, if you are using one of those more expensive, I would say, expensive rules in AWS WAF, such as bot control and so on, you have the way to manage that by scoping down the rules to where you need. The other trade-off is regarding, let's say, putting in place it's more about route management, right? So every time you make a route change, adding a route, removing a route, modifying a route, all of that happen in a single place, which is the single CloudFront distribution configuration, which becomes a kind of a monolith. So any mistake here has a big blast radius. You need to put a very proper CI/CD pipeline to manage those routes for you. Now, if you don't want to do it this way, if you don't want to kind of have the routes statically defined in the CloudFront distribution, there is a different way to do it in a more dynamic way. And the idea is actually to manage your routes directly in the key value store of CloudFront. So it's a distributed data store across all of the edge locations of CloudFront, in which you can define your different routes in a very dynamic way without touching the configuration of CloudFront. And the way it works is the following. Let's say you have like two CloudFront cache behaviors. One is for like the static content as usual, and the other one that catches all the APIs. So when CloudFront receives a request for an API on the second cache behavior, it will trigger a CloudFront function that you manage, right? Then the function will go and do a lookup in the key value store for the specific route. And then based on the response, the route that you defined, you will be basically routing the request to the appropriate API endpoint. And this was made very recently possible using the origin selection capability of CloudFront in CloudFront function. Note that using this mechanism, not only you can do routing, API routing in a more dynamic way, but you can do it also in a more sophisticated way. So not only based on path, but can be based on other attributes such as, I don't know, the location or other request attributes such as the cookie and so on. And you can do things like, I don't know, A/B testing and so on. So another request count. This is now for a different API endpoint, still managed by the same cache behavior. Then it will be, do the same thing, look up to the key value store, and then it will be routed to a different API gateway. Note that this, of course, has an additional cost. You need to factor in the cost of using CloudFront functions for every API call, together with a lookup request to the key value store. So remember, we did all of that to optimize the cost and performance of our web application. So let's talk a little bit more about this and focus on the API acceleration, like dynamic traffic acceleration using CloudFront. And to explain like how this works, I would start first with like in contrast, I would do the contrast with an API call made to like an API gateway. So like, let's say an API endpoint that is regional, that is not using any CDN like CloudFront, okay? So what happens is first, the user need to kind of establish the TCP connection using the handshake. Then establish a TLS session for encrypting the content. And finally, make the HTTP request. And all of that are happening on like a long, I would say, path. Okay, so it's a high round trip delay, RTT. Okay. Now, compare this to what happens when you are putting CloudFront in front of your API. So first, like the round trip is shorter. CloudFront is available, is present within tens of milliseconds of the major population worldwide, all right, with its 700 plus points of presence. Second, it is using a modern protocol, so you can enable HTTP3 with Quick. That allows you to combine the TCP handshake and the TLS session into a single round trip. Then from the CloudFront edge location to the API endpoint, let's say the API will be using the highway, which is the AWS global backbone, allowing you to benefit from a better reliability and a better performance overall, because it will happen with complete isolation from the internet, especially if the origin is hosted on AWS. And then a very important aspects of API acceleration is connection reuse. So here you see that the HTTP request went directly to the API without establishing a new TCP connection between the CloudFront POP location and the API endpoint, because we're assuming that there was already a connection that was established and we don't need to do it again. And there are ways to improve persistent connection reuse. For example, using timeouts, adjusting the keep alive timeouts on CloudFront and on your origin. Then maybe you are using some, let's say, more optimized API protocols such as WebSockets. This is possible, and we recently made gRPC also an option that is possible for you on CloudFront. And finally, for some of your API calls that actually do not require the advanced capabilities of an API gateway, right? Such as rate limiting, authorization, and all of that. You can actually simply integrate, let's say, your Lambda function with CloudFront. So Lambda, through using Lambda URL, can be configured directly as an origin to CloudFront with origin access control to kind of lock the Lambda to being executed exclusively by CloudFront, which removes an additional component, making it faster and cheaper for you to serve. Okay, so we talked about performance. It's important to measure it, to be able to improve it. So I'm gonna give you some hints on how to do it. So the first thing is to think about is measuring the performance on the server side. And one way to do it is using the server timing header that you can generate on your application and include the latency that was spent in different parts of your application. And you can enable it as well in CloudFront. So you can learn more on how the latency was spent across the layers of CloudFront. For example, in this case, we know that CloudFront did not need to kind of make a new DNS query to resolve the origin domain because it was already in cache, but it had to establish a TCP connection. So there was no TCP connection reuse in this case. If you have a lot of this, maybe you need to kind of tweak your keep alive as discussed before. And then we can see, for example, the first byte latency to the origin and some additional information that was added by the application. So I don't know, maybe like a query to the database that took half a second. So this information is available as a response header on the responses basically, but some of it is also available in the CloudFront logs. And I would like to share with you also that CloudFront logs have evolved recently. So the CloudFront team announced new destination to CloudFront logs, including CloudWatch logs and Kinesis data firehose, also allowing you to select which fields that you would like to send to the logs, plus allowing you to use additional formats for the logs to make it, let's say, easier for querying later on, such as JSON or Parquet with partitioning and so on. So please have a look at it. I think it can help you optimize your observability cost quite significantly. So we talked about server side visibility. To have the full picture, we need to also look at how the users are experiencing the performance, right? And we can do that using CloudWatch Run, which measures the performance using a client-side JavaScript and send it to the CloudWatch Run service. So you can have a look on, okay, how are my pages doing across the world, right? And they correlate quite well with Google core web vitals, which are important for your SEO and so on. The last thing is I would like you to kind of think about correlating both of them, right? So you have a full picture of what's happening from the client to the server, right? And there is a solution, a blog that talks about how to do it. Here's the QR code. You can scan it, and the idea is using a client-side JavaScript. Basically, we are going to read the server timing header, and we are going to append the information to the reported CloudWatch like data, performance data. Awesome. So that's it for this Chalk Talk. If you are interested in such topics, feel free to follow me on LinkedIn. I constantly post educational content about content delivery, web performance, security, and so on. Thank you very much, and have a great day, evening, morning.